Welcome to Machine Solutions Minutes. My name is Brian Beam, and today I would like to talk about thermal nozzles. Topics we'll discuss are going to be what types of machines you use a thermal nozzle for, proper nozzle selection, sizing for uniformity, and temperature verification and thermocouple positioning. A thermal nozzle is essentially a tool that is used at the end of a hot air heater to evenly distribute the heated air around the materials to be processed. There can be various types of machines that these go on, such as hot air stations for manual operation, horizontal laminators, vertical laminators, and even tipping machines. There's also many types of nozzles, many types with multiple ports. Some have 2, some have 3, others have 7, and some are fully enclosed, others are open style, and there's a good reason for each different type depending on the application and size of your material. So let's talk a little more about that. The Model 211. This is a dual port nozzle with 2 exit ports 180 degrees apart, and the height of that exit port is 0.187 inches. Therefore, we recommend a maximum product diameter of 0.125 inches for this type of nozzle. The reason for that is if you get much bigger, you're not going to get uniform distribution over the full diameter of your material. You're going to end up with hot spots near the exit ports and cooler spots at the top and bottom. This nozzle can be used for all types of processes, from narrow bonds, balloon bonds, even laminations in a manual fashion. So as long as your material does not exceed 0.125 inches, the 211 is a great choice. The 212 is also a dual port nozzle, but the slot is horizontal to the table versus vertical like the 211. This nozzle is best used for lamination applications or for automated hot air station applications in which the nozzle can shuttle in and out to the materials and engage them and then retract. So again, product diameters up to 0.125 inches, and typically for lamination, however, in the products like the AC280 automated hot air station, this is an excellent choice for narrow bonds, butt joints, lap joints, or balloon bonds, and can go down to as narrow as a 0.040 inch width. So it makes them ideal for very tight, precise applications. The 311. The 311 is a 3-port nozzle. There are 3 ports 120 degrees apart, and this is ideal for product diameters up to 0.375 inches. The 3 ports 120 degrees apart are going to ensure that you get uniform distribution around the diameter for parts up to 0.375 inches in diameter. So this can also be used for narrow bonds, lamination, butt joints, lap joints, balloon bonds. It's application specific when it comes to the width, and we can discuss that as well. The Model 312 is a horizontal version of the Model 311. This is primarily used, again, for laminations. It can be used for the AC280 systems in which the nozzle shuttles out to the parts and retracts. It is good for narrow as well as for longer length applications up to 25 millimeters. It's primarily used on lamination systems, but again, it can be used for the AC280 automated hot air station. The 312 XL is the same nozzle as the 312, but in longer lengths. Again, product diameters up to 0.375 inches, primarily in the XL, used for thermal lamination. The Model M360 full circular nozzle. This nozzle is primarily intended for diameters up to 0.75 inches. It has 7 ports. It has an internal flow chamber that balances the flow through all 7 ports to ensure that you get uniform distribution around your materials. This nozzle has the benefit of having sizing discs on the top and bottom that can allow it to be quickly tailored to a given diameter without changing the entire nozzle. This is advantageous in optimizing the distribution around the parts and the size of the part to the disc. Nozzle sizing. When we talk about diameter, this is a very, very important aspect of sizing. There's a general rule that you take your material diameter and you add between 200 and 250 thousandths of an inch to your material diameter, and that determines your nozzle diameter. It is not an absolute rule that you have to adhere to this. However, if you make that gap too small, again, you're going to get hot spots near the exit ports because the air is not allowed to flow uniformly around the entire part. So allowing enough airflow to get uniform coverage without getting those hot spots right near the exit ports. So you can have, let's say, for example, a 1/2 inch diameter nozzle, and you can process materials as small as 0.1 inch diameter. It's just going to be a little less efficient. It's preferable that you get into that 0.2 to 0.25 inch gap range for the best performance. The width of the nozzle is always dependent on the process. So if you're doing, for example, a lap joint, you have an overlap length of, let's say, 2 millimeters, such as in a balloon or two tubes overlapping. You're going to want to size your nozzle width to that dimension. Maybe slightly longer, but then you're just heating material that you don't necessarily need to heat. So it's best to minimize the width of the nozzle to the application being performed. So for a butt joint, you're going to want a very, very narrow nozzle width, such as the 40 thousandths or even a 0.1 inch, depending on the diameter of the material. For a lamination, if you're doing laminations on a hot air station manually, you're going to want the maximum width of 1/2 inch. For the 211, the 1/2 inch width is limited for reasons that the heating element is only 1/2 inch wide. Any wider, and you're going to start to have a delta of cooler air towards the exit ports on the sides, left and right. So thank you for attending our little presentation. We look forward to seeing you next time.
Excellent.
Something felt incomplete.
Oh, okay. What felt? Huh?
I don't know. I felt like I had more to say, but what did you think?
I thought it was good. Let's save the recording and you can watch it.
Okay, I might want to do it again because I might want to talk about longer lengths with respect to lamination and how that's advantageous. But let's hold that one for now, and let's get on to the next one.
Okay, so the next one I'll email to you. It's die heads, but let me see here. Hold on. 1 second. I'll forward this to you and then I'll come over to your desk, okay?
Okay.
Oh wait, I think we need to stop this session because I need to record it separately. Yeah.
Do I do that or
end. Huh?
Go ahead.
Okay. I'm gonna end this session and then I'll create another link for the die heads. Be right back.